Okay, we're going to talk about analysis of variance and the different types of variation you find when you're analyzing sets of data. Okay, first you have variation between groups. This is a weighted sum of variances between the sample mean and the overall mean. If it's big, it means whatever factor you changed probably affects the system, and if it's small, it means that it probably didn't affect it that much, and all of the data is from one set that's normally distributed. We have the equation here for sum of the squared variations between groups. It's using the numerator, the F statistic, and the degrees of freedom for this measurement is k minus 1, where k is the total number of groups, n is the number of measurements in each group, x1, x2, and x sub k are the means of the group, and x is the overall mean of your data. Next, we have variation within groups. This is a weighted sum of variances between data values and the sample mean of each group. If it's small, it means you have high precision within your groups. The equation is for the sum of the squared errors, where S1 is the variance of each group. This is used in the denominator of the F statistic, and the degrees of freedom is n minus k, where n is the total number of data points and k is the number of groups.
For total variation is the total sum of squares. It is also the sum of the variation between the groups and the sum of the variation within the groups. So as you can see in our equation, SS total is the difference between the individual data points and the overall mean squared. The degrees of freedom for the total variation is just the sum of the degrees of freedom from the previous two slides, and that ends up being big N minus 1. The F statistic, as we've been mentioning, is the variation among sample means divided by the natural variation within groups. The numerator is determined from the SS groups, the sum of the squared of the groups, divided by its degrees of freedom, k minus 1. The denominator is determined from SSE, which is the sum of the squared errors, divided by its degrees of freedom, which is big N minus k. The F statistic value will test the null hypothesis, which states that the factor that you're testing does not affect your output.